the presentation, please type them in the questions box anytime. We will address them at the end during the Q&A session. Now, I would like to introduce you to today's moderator, Jason Nadeau. Jason, take it away.
Great, thank you, Ashley. A pleasure to be here and host the webinar. So I am the head of the marketing organization here at Dremio. And just before we hand off to the main event here, I'm going to just kind of give a quick point of view on Dremio, but I'm really super excited to have two folks from the Eckerson group to give you their perspective on the market and what's happening with data lake engines in general. And so first, we've got Wayne Eckerson, who is the president of Eckerson Group. Wayne will be kind of giving us the broader market overview. Wayne, great to have you here.
Great to be here, Jason.
Yeah, thank you. And we also have Kevin Petrie, who's the VP Research over at Eckerson Group. Kevin will be running through the rise of the data lake engine architecture and whatnot, and looking forward to kind of having that discussion. So Kevin, welcome.
Thanks, Jason. Great to be here.
Okay, so with that, let's get in quickly. So next slide, please. Gotta love the the internet delays, right? So again, just going to spend a few minutes briefly before we hand over to Wayne and Kevin. So from a Dremio's point of view, right? Really, this is why we exist. We see that the growth of data in data lakes, cloud data lakes in particular, S3 and AWS and ADLS in Azure, that data is exploding, but it's really hard to access. Data teams everywhere. Whether they're data engineers and data scientists, or they're kind of front end BI users and analysts, they have a real tough time getting access to that data. It takes a long time to get data sets configured. Query performance is really slow. It's difficult. It takes a lot of heavy duty skill sets, frankly, to try to get access to the data in the data lake. It's just tough. And what we've seen as a result of that is that organizations and data teams can revert back to the traditional data analytics framework, which is all about ETLing data back out of the data lake in this case, putting it in a data warehouse somewhere, going through all that work takes a lot of time and an effort. Still, typically performance is not fast enough, particularly for BI dashboarding and reporting. And so you see a bunch of cubes and extracts and aggregation tables and other things. And that's the picture on the right? So it's like you end up with a bunch of data movement and copies, loss of control of the data, as it goes into proprietary formats, and just all these copies that are hard to manage. They're ungovernable. You really don't know kind of like what the source of truth is, and so on. So like, that just makes life really, really tough. And so the whole picture has not been great. Next slide. So we come along to essentially our point of view is we fix this problem and tackle it head on. And so what we're doing is we're allowing organizations to keep the data in the data lake where it is. Don't copy and move it out. And the way that that's possible is with lightning fast access. That's really the big enabler here. So we're bringing lightning fast queries right to data where it sits in the data lake from the front end tools that you're used to using. Again, could be Tableau or Power BI, Looker, these sorts of things, or data science tools as well. But you get to access the data right where it is with really, really big kind of next generation performance improvements. So you think about compared to a legacy traditional SQL engine like a Presto, 100 times the BI speed, right? So that you're getting sub-second a BI query access. Ad hoc speeds 4 times faster than those traditional engines, and all without creating all these cubes and extracts and whatnot. So Dremio is doing all this with a bunch of things that are just built-in acceleration, right? Without having to create copies and all the rest. So just providing that access, and then we couple that with really extreme compute efficiency that reduces cost and ultimately, reduces risk too, because we're avoiding a bunch of these copies and whatnot. But you think about the running in the cloud. The beautiful thing about the cloud is you can kind of bring whatever compute capacity you want, but the cloud is not free, right? And so what we are really focused on is making sure that we can deliver this extreme speed with the least amount of cloud compute resources possible. So, again, compared to the traditional, call it Presto-based SQL engines and others that are like that, you're going to get about 1/10 of the infrastructure required out of Dremio. So at the same level of performance, right? Again, you can bring as much cloud compute as you want, but we're going to be way, way more efficient. So pound for pound, Dremio is a much more powerful and efficient way to get the value out of your data. So that's the sort of just a quick Dremio point of view, and we're really excited to have Eckerson come in with theirs, right? Dremio is one vendor in the marketplace, and Eckerson talks to lots, and they get to have their pulse on kind of what is happening generally speaking. And so with that, I'm going to hand the baton over to Wayne, who can take us through the state of the market. So with that, over to you, Wayne.
Thanks, Jason. It's great to jump right to the conclusion there. I'm going to back up and give you guys the 30,000-foot view of the market, and then I'll turn it over to Kevin to dive into some of the more technical details of how do you do what Jason just talked about. So Kevin, next slide. And next slide. We've been examining, we're a research and consulting company that specializes in data and analytics. And for many years, we've been looking at the rise of the data lake and how it compares to the data warehouse. And as you can see on this slide, in almost every single characteristic that you can count, these two environments, data lake and data warehouse, are completely the opposite of each other. Next slide, completely divergent. So the thing is, our clients on the consulting side want both of these environments. Just keep clicking, Kevin. So they want the data lake to support their data scientists who really want access to the raw data. And they want a persistent store for all the data, not just structured relational data. They want semi-structured, they want unstructured data to store in there, audio, video, text, social media data, sensor data. So a single place for data scientists to explore all this raw data and easily create data pipelines from it. So they want that, and they want to use a subset of that to feed into the data warehouse to create a repository of trusted dimensional data to deliver fast, predictable performance for queries running against dashboards and data marts. And they want to create a zone of trusted data that's governed and users will use because they know it's right. So what we see is our clients are stitching these two environments together. And as Jason pointed out, there's a lot of risks involved in that. There's a lot of data movement, a lot of complication, and a lot of redundancy, frankly. So next slide. So, the vendor community is very in tune with what's going on in user environments. You're going backwards. Well, I guess not. That's not backwards. And they're trying to race to unify these two worlds and bring the best of those two worlds that are completely opposite together in one environment, so people don't have to move the data at all. So they can support both data science and BI workloads. Can support SQL as well as other languages like Python, Scala, and R. They can, have schema flexibility, which means if you don't need to model the data up front, you don't have to. They want read-write ability, ACID transactions, ability to update files as well as append, support any data types at any scale, streaming and batch, high performance and high user concurrency. So that's the goal. It seems like a holy grail, really. But companies like Dremio and others are really trying to figure out how to do this. Next slide. And what we've seen is that, there's a lot of contenders out there in this marketplace, and they're all coming from a different perspective. Some started in the data lake space, like Dremio and Databricks. And some, started in the data warehouse space, like Snowflake Microsoft, which now calls its data warehouse offering Synapse. And what we're seeing is that they're all kind of moving in the same direct. Well, they're moving towards the middle to create an integrated platform that combines the best worlds with different technologies, different approaches, and different techniques. So it's a very interesting market right now. And I'm going to turn it over to Kevin, who's really going to take a look at how the data lake vendors are providing this integrated platform. So Kevin, it's all yours.
Thanks, Wayne, and thanks, Jason. Thanks, Dremio, for making this happen. As both Wayne and Jason said, we're at a very interesting point. I think it's fair to say it's an inflection point where you have a convergence of worlds that are starting from very different vantage points. And if we rewind, say, 5 years, the emphasis was the data lake will not replace the data warehouse. They do very different things and can complement each other. And the reality of what enterprises are doing now is a little more nuanced, which is that the data lake does in fact have some very real advantages to offer to data warehouse type environments. And in fact, BI users, traditional structured data BI workloads, are finding a new home on the data lake because of the resulting advantages. So let's unpack what exactly is happening. The Cloud Data Lake engine. To set the table here a little bit, I just want to talk briefly about the evolution of the data lake. We're in decade 2, and I think we know, most folks on the call, the brief story of the first generation. You had batch-oriented workloads driven by, say, MapReduce. You had storage systems that were based on the Hadoop file system, and most of the traditional data lake environments were based on premise. And while a lot of the innovative Apache components offered interesting innovation opportunities, they were pretty complex. They required real programming expertise to manage. And I think the fundamental problem, though, was that the first generation data lake, typically based on a prepackaged stack of Hadoop components, could be very inefficient for architectural reasons. Data teams struggled to manage and tune the underlying resources in order to meet various SLAs. And this is true with other data environments for on-premises workloads. So you have compute and storage that were coupled within each node and they couldn't scale independently. As a result, resources were not being truly utilized. Service levels were getting broken, costs were escalating. And so there's also this inability to isolate workloads so that they're competing with each other. So from a performance perspective, things are kind of a mess with the first generation. So Hadoop starts to fizzle due to complexity, due to cost and inefficiency. And now the cloud service providers start to roll in with the second generation of data lakes based on cloud native object storage, S3, ADLS, or blob storage, and so forth. Now these Gen 2 data lakes are faster, they're simpler, and they're more efficient. And those are kind of the three themes that we'll work through with this webinar, which is speed, simplicity, and efficiency, because we're continuing to make advances on this. So the first point is that Gen 2 data lakes are faster because they're starting to use in-memory processing, such as Apache Spark, to reduce latency and improve throughput. So they're getting closer to the performance levels that you need for mainstream BI use cases, such as scheduled or ad hoc reporting and so forth. Gen 2 data lakes also simplify management because you have the CSPs platforms that are starting to offer automated tools and services to address data management and advanced analytics. So we're starting to reduce a lot of the scripting complexity and reduce the skills and programming training that's required for folks to get some value out of these platforms. Now, the third point is that Gen 2 data lakes can operate more efficiently. And this is because of the move to the cloud. Object stores, cloud storage, and compute resources now can scale up or down separately and on demand, which is much more efficient. You're not throwing too much compute at a cold data set, and you're throwing enough compute at a hot data set, and you're only paying for what you use. So there's significant advantages here. With that said, there's more work to do. The obstacles are familiar. First being speed, because object stores do have some latency here. They weren't architected to handle, in particular, structured or semi-structured data. They can do it at high scale and low cost, but because of variations in ways that data is stored within these object stores, you can have erratic response times, and that starts to be a real problem. So this creates the need to have data lakes that start to reduce your trips to the object store, creates the need for more in-memory processing. And then we have complexity. Data teams have been forced to build these performance workarounds, which Jason talked about earlier, that make it harder to access data. In order to get the performance you need for a BI tool, oftentimes enterprises are exporting data to aggregation tables, OLAP cubes, BI extracts. So they're getting the speed you need, but these are now independent, overlapping, duplicative copies of data that create a governance mess and make it very inefficient to access your data. So the Cloud Data Lake Engine, and you're going to see some terminology vary among vendors, but I think that there's been strong validation of this architectural concept. What we're doing now is organizations are getting even more serious about performance. They're using columnar processing, they're using parallel processing, they're using prefetch algorithms and virtual data sets. So they're starting to make the most of data in memory so that you can reduce those trips to the object store. The Cloud Data Lake Engine also has, and it's very important, a consolidated self-service semantic layer. And so what's happening here is you've got the ability to run a SQL query and then have the data returned, usually from memory, and you can start to reuse the virtual data set that you've created and is remaining within memory. You can reuse the schema and you can reuse the data itself. And because this is one self-service semantic layer that stretches across your data lake, you've reduced and improved the governance picture, because you don't have a lot of duplicative copies of data. You have one set of very reusable formats that are existing now within memory. And now you're also starting to reduce your footprint and your compute in ETL. So it's even more efficient. And some of the reasons that this is happening is that analytics workloads are consuming fewer compute cycles. Cloud platforms offer independently scalable storage and compute resources, and you can have the Data Lake Engine automatically deactivate CPUs during idle times between jobs. So that's going to save you money and it's going to improve efficiency. So this is really achieving at a more granular level what Wayne talked about earlier, which is that you're taking the performance, the structural and governance advantages of the familiar traditional data warehouse, and you're putting that on top of the true advantages of cloud data lakes and cloud infrastructure, which is they're open architectures, highly scalable, highly elastic, and very efficient. So the benefits here of the Cloud Data Lake Engine are that obviously if you can analyze more data more rapidly, then you can deliver more value to the business. And that's a fundamental premise that certainly makes sense here. And it contributes to the second point, which is that there's a real shift and a real democratization of data access. It's not simply the purview of BI analysts, and it's not simply the purview of data scientists. More and more business managers want to roll up their sleeves, especially in this uncertain economic environment in which we've got some major structural changes in the economy. More and more folks need to look hard at data. And the Cloud Data Lake Engine, if architected well, and if you have a solution that automates a lot of the pieces, can empower more and more business-oriented analysts without data engineering background, without programming skills, to get slices of the data, and to do it in a way that's still well governed, because they're going to reuse a lot of the same structures and formats that their predecessors have used. So the Cloud Data Lake Engine is a faster, simpler, and more efficient method of managing this query and semantic layer. Okay, so let's put this in a bigger picture, which is that CIOs and CDOs are pursuing a number of complementary initiatives. Cloud migration is no secret. There's been a huge shift that's only accelerated in the wake of COVID-19 to infrastructure as a service because it will provide an open and economic method of hosting your IT workloads, and to do so in an elastic way so that you only use what you need when you need it. You can scale up and down, and you can pay by the drip. Those advantages have been driving a huge shift to the cloud that really has only accelerated, because I think that one of the results of the Black Swan events of 2020 is that more and more enterprises need to get online fast, and you've got a huge move of late adopters to telecommuting, to hosting business models and engagement models on the cloud. And so this is a big shift, and as folks do this, enterprises in particular need to get much more strategic about what they're doing with the data lake. There's the opportunity to put the BI workloads on there, and that's where the Cloud Data Lake can help. There's also a shift to self-service. And so this is part of the data democratization theme that I talked about earlier. Analysts and managers want to tackle BI, make more data-driven decisions without waiting on overburdened data engineers, ETL developers. And with these types of automated tools and this data lake engine, this consolidated semantic layer, they can start to do that. There's also a huge shift towards advanced analytics. No secret here. Machine learning is becoming more and more of a mainstream feature of different business processes. And so that push to pursue AI projects such as machine learning is driving demand for low latency, highly scalable cloud data lake environments. And the data lake engine really helps because it very quickly helps you return requests for structured and semi-structured data, which a lot of machine learning workloads depend on. Okay, so if we unpack this a little bit further and look at use cases and roles, faster BI is a direct benefit, and that's the experience of the BI analyst. You've also got BI analysts, business managers, and data scientists reducing their dependency on data engineers with a self-service approach. The next two here, streamlined data engineering and standardization of the semantic layer, are use cases that are addressed by the enterprise architect or the data architect and the data engineer. So they're reducing the amount of work required to meet business requirements. They're also standardizing the structures and the data that's returned with virtual data sets in memory, so that you can have much less data, much less duplicative data to govern, and then that has a real benefit for the data steward as well. The final two here, data exploration. The data scientists with the data lake engine can get a unified repository. One of the initial promises of the data lake when it arose with Hadoop and the yellow elephants over a decade ago was you could throw everything into it and get one view. And it's taken a long time for that to actually bear fruit. It's certainly not there yet, but with the Cloud Data Lake Engine, you can get a view and you can start to explore your data, all the structured data, all the semi-structured data, and unstructured as well. And you can start to, if you've got the right solution, join with data that might exist in other places as well, databases and so forth. So it's really going to help you explore the data and understand what you're dealing with. Final point here with feature engineering, data scientists want to identify the most actionable attributes as they're putting together machine learning workloads and models in particular, and the data lake engine can assist with that. Okay, so I've got architecture here, and I won't spend too much time on this, but I want to talk about some fundamental characteristics or attributes of a cloud data lake engine architecture. The first is the centralized management and access. As I showed on the prior slide, you've got a number of different types of people that need to access data, and they're going to do so in order to answer a lot of different business requirements throughout the organization. The Cloud Data Lake Engine will centralize the management and administration for data engineers in particular. And then you've got BI analysts and data science who can gain a central interface for accessing the data. The final point here is collaboration, because the analysts and data engineers can work together to create and reuse virtual data sets that exist and persist within cache. There's real-time querying. So data consumers and data engineers of all types leverage a very familiar structured query language, SQL, to structure, manipulate, query, and control access to structured and semi-structured data. There are different types of running queries on data lakes. SQL is going to be a common denominator, and it should be a requisite capability, because it is, as we know, the lingua franca of the BI world. Data scientists, for their part, might use languages like Python for specialized processing, in addition to SQL commands for data preparation and querying. The consolidated semantic layer, we've talked about this already in a fair amount of detail. I think the additional point would be that this semantic layer can help centralize KPIs and business logic, so that you're reusing data sets that have been used before, but also the business logic, so that you have a consistent set of reporting formats across the business. Multi-tenant infrastructure. So the Cloud Data Lake Engine is going to rely on a shared environment that provides all your users with the necessary views into their data sets. However, separate workloads can be configured to run on distinct partitions of files and object storage, so that you're leveraging independently scalable storage and compute resources. This will help reduce resource contention, and you could have sort of a zoned approach where the hot workloads, the latency sensitive workloads, can reside on their own dedicated object storage with their own compute available to them. Automation is a common theme across the stack, and I think that it's become the gospel of our industry, because if you can reduce the scripting that's required, in particular of those overburdened data engineers, of the BI developers and everything in between, you can speed up what you're doing and realize higher output for a given unit of input. And then the open architecture, it's a final point here, but it's a really important one, which is that it's critical to avoid creeping lock-in. And this is those unanticipated, gradually accumulating obstacles to data and application mobility. It's critical as you look at the Cloud Data Lake Engine architecture, you embrace and seek out open formats, open APIs, and flexible capabilities that integrate with many environments. So here we're talking about open file formats like CSV, ORC, JSON, and with APIs we're talking about ODBC, JDBC, and others. Okay. In the summer theme here, we've got the notion of diving into the data lake. The water's just fine. I think this is an architectural approach that most enterprises that are looking to improve the efficiency of their BI workloads in particular and start to consolidate their platforms should consider a Cloud Data Lake Engine. And it starts with incremental change. As with a lot of initiatives, if you can layer onto your existing architecture and avoid a rip and replace, that's going to help a lot. And this particular technology works well for that, because we're talking about layering onto S3 buckets that most organizations have, layering onto ADLS that most organizations have. Be sure to research your options. There are a range of commercial and open source components, Arrow, Apache Arrow, Dremio, and others that are available to you. And I think the short list of must-have features would include real-time support, so really getting the latency down so you can have those interactive BI workloads. What are the methods of compute, and are they going to lead to runaway or surprise compute costs? Be careful on that one. Automation, reducing the developer workload, and interoperability to get to that open architecture I talked about. And then the final point here would be with that, as with a lot of initiatives, if you can find pain and alleviate that pain with a relatively straightforward, narrow scope initiative, you can get some benefits. You can win some political and dollar capital in order to expand budget for addressing additional teams, use cases, and so forth. Okay, so I think I'm going to hand back to my colleague Wayne. He's going to wrap up with a little bit on Eckerson Group, and then we'll go to Jason.
Thanks, Kevin. That was great. A good detailed look at technology behind the data lake engine. I mentioned before that Eckerson Group is a research and consulting firm focused just on data analytics. Most of us know us from our content, research reports, webinars like this, and various articles. Next, Kevin. We also do strategy and design work for a lot of companies around the world. And there's a list here, of some of our recent clients that we've been honored to work with, helping them build data strategies, data governance programs, self-service analytics strategies, master data management designs, and other things. And next. I think the next question is just Q&A time. So Jason, it's all yours, I think.
Excellent, thank you guys. That was really good. Really appreciate the overall kind of like landscape, Wayne and Kevin, really the deep dive into what is sort of the rise. First of all, what is the data lake engine, and kind of like why is it important? Not surprised that we agree, with a lot of this, right? It's as you saw from sort of the top, it's very much the problem space and the sort of the approach that that we're taking here as well, because we believe this is what organizations and data teams need. So with that, let's get into questions. And so we've got a number of questions in the Q&A panel. As a reminder, anybody can go in, just write into that Q&A panel, type your question. We'll see it come up on our side, and then we can just ask it directly here. And of course, if we don't get through them all, that's totally fine. We'll follow up with folks individually after the webinar. So first question, and these are going to Wayne and Kevin. I think this is probably going to be more for Kevin, frankly. So Kevin, for you, can you elaborate on how to, more specifically, avoid cloud provider lock-in?
Great question and popular question. What's really interesting about this is that a lot of companies have embraced the cloud. That's no longer a big choice for organizations to become a mainstream given. But a lot of organizations are also looking at two cloud service providers. They'll start to do some of the more specialized workloads on one CSP versus another. Maybe Azure or Google are particularly good at a certain machine learning algorithm, and they'll want to experiment with that. And as that happens, it'll become more and more important to be able to move between clouds. And I think that it's like a lot of things. If you can have technical debt pile up quickly. As organizations embrace the cloud, infrastructure as a service is a good bet. It improves efficiency and cost and so forth. When you start to use PaaS tools, when you start to use platform as a service or cloud service provider specific tools, that's where you can start to get into their APIs, which may or may not remain open, their data formats, which often require some work to get out, and their data extraction costs. So it's important to try to scope all that upfront as much as you possibly can. And then you can know 3 years down the road, you can have fewer surprises if you need to migrate that new machine learning workload back to AWS as an example.
Yeah, makes good sense. And here's another one for you. It's kind of, I think, related, given the cloud conversation. So question for you, Kevin, is what are the right evaluation criteria for cloud provider data lake platforms, whether they're, Amazon, S3, EC2, ADLS, and so on?
I think that the open architecture is critical, and so that just builds on what I was saying earlier. First, making sure that you have open APIs, you have formats that are easily transferable to a variety of engine environments, and then CSV, ORC, JSON come to mind there, and Parquet as well. Another important criteria would be looking at performance characteristics in architectural approaches, and actually maybe doing a specific bake-off, because performance is really critical. And there's an assumption that Spark could solve all the problems, but it doesn't necessarily. There's more you could be doing, for example, with Apache Arrow. So looking at performance, looking at open architectures, and looking at cloud lock-in, those are I think 3 critical evaluation criteria.
Okay, great. Here's another question. What are some common machine learning use cases that leverage cloud data lake engines?
So it's interesting. I think that there's been an assumption in the market when we started on the AI journey that it would do a lot with unstructured data, and it certainly does. But with that said, a lot of these workloads are focused on semi-structured data, or I should say semi-structured or structured data. And so we've seen a number of machine learning use cases that are amenable to the cloud data lake engine approach that look at anti-fraud algorithms for financial services companies, that look at new ways to assess customer requirements based on purchase histories and things like that. So making new use of the data and faster use of the data that exists in columns and rows. Those are some of the things that jump to mind if you're looking for the benefits of the cloud data lake engine.
Okay, yeah, thank you. Just on the sort of the concept of data lake engines generally, here's a question. What's the difference between a SQL query engine? Because there's SQL query engines have been around for a long time. What's the difference between a SQL query engine and a data lake engine?
Good question. Part of it would depend on who's using the term and in what context. I guess what I would emphasize is that in the evolving industry architectural approach that we're seeing has SQL as a component, a must-have component, but it doesn't stop there, because it's really critical to have the semantic layer in order to simplify a lot of the governance aspects. So it's really fundamentally a different approach. It's using SQL queries, using the consolidated semantic layer to eliminate a lot of that sprawling data warehouse structures, BI extracts, aggregation tables, OLAP cubes, and so forth. So those are some larger attributes of this architecture that you need to keep in mind, and not simply assume that a SQL query method will solve the problem.
So I have a question for you two guys. One of you, I can't remember who, mentioned that the semantic, or kind of inferred, unless I heard it wrong, that the semantic layer is created from a cache, which made me think, okay, so every day you want to run a whole bunch of queries that populate the cache that create essentially the data sets that you want people to be able to access. Did I hear that wrong? Or maybe you could elaborate on how that semantic layer is built.
Well, I'll go. This is Jason. So,
sure. Jason, you want to go first?
Yeah, I'll go. So from a Dremio point of view, yes, that's not true. So the cache for us is just part of the overall acceleration. So we've got a number of different acceleration technologies that work in concert with our core Arrow-based engine. And one of them is what we call our columnar cloud cache, which is caching the data as it's coming up out of the cloud data lake storage. Call it S3, for example. And so that way we can take advantage of NVMe speeds once that cache is warmed up, because it usually gets hit by queries a lot after that. We typically find like kind of like 10 hits for for each warm up, so it's like a 10x huge, or a lot more actually, in fact, huge increase in performance there. But that's not the semantic layer. That's just query acceleration. The semantic layer is getting built by this this layering on of virtual data sets. So there's a bunch of physical data sets in the environment. Of course, lots of different types of structured and semi-structured data in the data lake. And data engineers are going to take those and they're going to make them available, but they're not going to pass them through to the data consumers directly. That's the whole point of the semantic layer. We want data consumers, data analysts, end user BI folks, data scientists, et cetera, to not have to worry about knowing and understanding the actual physical layouts of the data. We want them to work with virtual representations, virtual data sets. And that way there's no copies, there's an easy ability to make changes and create different views of the data without copies, without governance challenges, with full lineage and all of this. And that allows people to define things like, what's a work week? Does it start on a Sunday or does it start on a Monday? And have this layering of virtual data sets that other people build more virtual data sets on top. It allows for a consistent and common set of KPIs and business logic and so on, so that all of the visualization tools, again, Tableau, Power BI, Looker, and so on, can all use that and get a consistent view. So it's all about virtual data sets to make that semantic layer. It's not about the caching, for Dremio anyway.
Yeah, so are you guys taking the existing, are you building that? I assume someone models that semantic layer, and are they using, whether they kind of have their virtualization, your virtualization engine can query and see all the data, and then someone builds views on top of that, renaming columns, maybe pre-joining, logically joining, certain tables and things across within a database or across database. Is that how it works, or are you modeling it logically without the data to start?
Yeah. So it is a type of modeling, right? Building these virtual data sets, and you think of them as views, like you said. And so that starts with data engineers. They're the ones, because they're the ones that are closest to the data, actually the actual physical data in the data lake. It may be outside of the data lake too, but most of the data is in the data lake these days. That's in the cloud. That's what we're built and optimized for. So it starts with the physical data sets, and then they'll create the first set. The data engineers, I should say, will create typically that first layer of virtual data sets that then expose the physical data. Usually there's going to be some joins and some other things as well, right? That start to pull stuff together. But then even the data analysts can start to get in and say, okay, I'm going to take this virtual data set, I'm going to kind of merge it with, or parts of it with, another virtual data set from that was created over here. And so then this modeling begins to occur, where people can can find and work with data and different views of data, also based on role. One of the things that data engineers can do with Dremio is control who can have access to what data, right? Things could be, columns, and could be masked, for example, or just not have access, or give specific folks access to some data and not others. So all of that kind of gets modeled by this combination of data engineers and even the data consumers, like the data analysts, that are ultimately going to work with the data to build their reports, do their ad hoc queries, and so on.
Great, thanks.
Yep. Okay. So back to. Sorry, Kevin. Did you want to add a comment there? Sorry.
Well, I could add do one quick point on architecture. I think it's an important distinction that Wayne, you and Jason are making. That the semantic layer and the virtual data sets will make use of cache, but it's not correct to say that they're one and the same. Definitely agree with that.
Yeah, exactly right. Okay, so Kevin, another question for you. What training
Sure.
and skills are required for data engineers and BI analysts to use Cloud Data Lake Engine?
I think SQL is important. I think that it's also important to have I think the traditional background matters, which is understanding how data ETL works and so forth. But the key thing would be that you don't need to have the scripting expertise. So if you understand your data environment and you understand traditional SQL commands, you can come in and very quickly get up to speed on using a well-architected cloud data lake engine solution.
Sounds good. Okay, and I think really kind of two more here that that have come in, and so the first is, I think this is more of a clarifying question, be a pretty quick one. Does data get ingested into a data lake engine, like a data warehouse?
So the data will get ingested into the data lake, and go through a process that might well involve some transformation of data, but you're going to ingest it into the data lake, so that's residing within the cloud object store. And from that point, the query engine is going to retrieve data from the cloud object store and then create those virtual data sets that can exist and persist within cache. So the short answer is no, it does not get ingested into the data lake engine per se, but the data lake is going to create that virtual layer, the virtual data sets that can be leveraged for ongoing queries.
Got it. Yeah, and I think that's really important, right? The whole idea is to keep the data in one spot, not to be making a bunch of copies of it, moving it around, and ingesting it into various different things, because that's how you get all this crazy sprawl and complexity, right? So yeah, having an open data architecture where different tools can come and access the data, I think is the right way to go. Okay, and so here's a question. Not everybody's in the cloud. Some people, and I think especially large enterprises, have on-prem Hadoop data lakes. So what are your thoughts on those folks migrating Hadoop data lakes to the cloud?
I would think that it's a natural evolution and a given that that's where the future is for a number of reasons. The question of whether you should pick up and move an existing on-prem data lake to the cloud is trickier. My recommendation would be to take an incremental approach and say that for all the right reasons we've talked about here, efficiency, simplicity, open architectures, and so forth, it makes sense to move to the cloud. And so that's where you should start to optimize new workloads. You could take specific projects, specific data sets, and migrate them to the cloud so that you're over time replacing your on-premises data lake and your Hadoop data lake. I don't think anyone sees too much of a future in the Hadoop file system. And if you can move stuff to some of the Parquet or other types of formats within object stores, that can make a lot more sense. So incrementally move away from what you've baked into your on-premise system, incrementally start to build onto the cloud. And that's true of a lot of other types of data platforms as well.
Yeah, we see much the same. Like organizations that we work with, they're some of them sure are trying to migrate, but most of them are saying, hey, look, we'll keep doing what we were doing. Like we kind of have those platforms serving certain use cases, but every day there's new data that's getting created and it's getting put in the cloud, and that's enabling new use cases. And so their investment is really shifting into the cloud, and it becomes less about, frankly, migration. It becomes more about, hey, let's just do all the new stuff in the cloud and do it in a modern way with this open architecture, and in our case with Dremio driving it.
Yeah.
So another tools too, right? That's the whole idea.
I'll let you finish. I was just curious if you could comment on some of the most common use cases you've seen, analytics or data science, or I should say BI or data science, for folks making use of your cloud data lake engine solution.
Yeah, I mean, for us specifically, I think the biggest one really is end user BI. So there's all this data that is now available to bring to bear in combination with the traditional operational data, and there's a lot of that new data, right? And so moving that all into a data warehouse has been really a struggle. And so it's sitting, think clickstream data, right? For example, IoT data, all sorts of various different types of data. There's more coming, every day. and different types of it. And so, from a business intelligence point of view, where you really want fast access to that, to that data, fast queries, dashboards and reports updated, you can't afford to wait, 10 minutes or 8 minutes or, something for like any query to refresh in your Tableau environment, right? I mean, you can't do the sort of the speed of thought flow of analytics in those with those kind of times, and they could even be a lot worse than that. So BI directly on the data that's in the data lake is really the main thing that people consider Dremio for, because it's like impossible, any other way or without going through all these other machinations of cubes and extracts and whatnot, which slows down time, adds cost and complexity. The data's no longer fresh, and so on and so forth, right? So absolutely, it's BI, but the data engineering thing, gets really simplified as well. So if it's kind of like the flip side, right? So the data consumer loves Dremio to be in the environment because we just make everything fast, and they can go, do their job, find new insights, get those new insights way faster. But for data engineers, we make them way more productive. So that's that use case of just simplifying, accelerating the amount of value that a data engineering team can deliver is also a big reason for Dremio in the data lake. I mean, you think about all the ETL that you talk about ingesting into the data lake, right? Well, I mean, a lot of data engineers spend their time ETLing data out of the data lake into a data warehouse somewhere, and we eliminate the vast majority of that, right? Because there's some use cases that still make sense to go in the data warehouse, but you can do a lot now with Dremio right in the data lake. And so we cut out all this ETL. We make it way faster and easier to work with the data analysts to share and collaborate around these virtual data sets. And so data engineering, just kind of like level of effort, goes way down with Dremio, and that's another big one. And then the smaller ones are but still interesting, are around data science. But the big driver is really BI, end user, driving end user BI, and the associated kind of data engineering simplicity that goes along with that.
Yeah, it's definitely a recurring trend in so many areas, which is easing the life of the data engineer, because everyone benefits from an efficiency perspective. Yeah,
there's no question, right? We've seen, and we've blogged and talked about this, had other webinars too, about productivity, especially right now in in the world we live in. There's a lot more cost constraints, and in general, how can we help people to do more with less? And so spending less money in the infrastructure, which is something that I mentioned at the beginning, we absolutely help that. But boy, productivity is a big one. If you can make teams, especially from an analytical perspective, get more value out of the data with fewer people. It doesn't mean you need fewer people necessarily, right? But it means like you can be more competitive, and you allow those people to, because you can find more insights, right? You can do more of the true analytics that's going to lend to those aha moments, and so we're really helping to drive that out, and give those data engineers more time to spend on the interesting stuff, right? Not the mundane, kind of grunt work that they find themselves so often buried in, just in terms of trying to keep up with the data change requests coming from these front end BI teams, again in particular, but data science teams too, right? I mean, the requests come in from all sides, and it's just a lot of work. And so that productivity benefit to turn that around quickly with this, from Dremio's point of view, right? The built-in semantic layer and all these virtual data sets is just way faster and simpler. Okay.
Definitely agree.
Any kind of final comments? I think we're good for questions now. We're right basically at the top of the hour. If any other questions do come in, by the way, folks that are listening, if you didn't get a chance to ask and something comes to mind, send the questions to contact@dremio.com. We'll absolutely get right back to you. With that, any kind of closing words from Kevin or Wayne? Thank you for joining.
I don't think so. Great opportunity. Really appreciate the discussion, and I hope this was useful for folks online.
Right,
Yeah,
Jason,
absolutely.
it's a pleasure to be here with you and your audience, and I hope we added some value, and I look forward to continuing to exploring this topic with you in the future.
Excellent. Thank you both for being here. It was great to have you. And thanks to everyone who attended, and enjoy the rest of your day and the rest of your week. Signing off.
Very good. Thanks.